Recording in progress.
So I have explained this odd and even function in last week. So I will just briefly go through with what is this concept. So this one is needed when we are doing Fourier transform. So we cannot skip this part. So the first thing is not all function. We cannot say that each and every function is either odd or even. There are some function that does not satisfy this condition, odd or even. So, if some function is an even, we can say that a function is an even function if that function satisfies the condition f of minus x is equals to f of x. That means if we take an example. So let's see. There are some set of example. Let's see this first example. I'm going to do that one. The problem is f of x is equals to x to the power 5 plus s. Let's see, f of x is equals to, Miss, may pen on it? X to the power 5 plus x. So we are going to check whether this function is an odd function or an even function. So we are going to check this function is odd function or an even function. So what do we need to do? So if we are asking to check this function is odd or even, then what do we supposed to do? We have to starting from f of minus x. So we are going to consider f of minus x. So that means we have to replace all the x terms in that function by what? Minus x. So we can write this as minus x to the power 5 plus minus x. Okay, then tell me minus x to the power 5. What is it? We can say that this is equals to minus 1 times x. So we are asking to find the fifth power of this. So we can write this as minus 1 to the power 5 plus x to the power 5. Minus 1 to the power 5. Rina eke odd power එකක්. මොකක්ද උත්තරේ? Is it minus or plus? ඍණ සංඛ්‍යාවක ඔත්තේ බලයක් වෙන්නේ හැම වෙලෙම ඍණ එකේ ඔත්තේ minus. ඒක even power එකක් නම් තමයි ඒක plus වෙන්නේ. So this is equals to minus 1 and this provide x to the power 4, x to the power 5. So what is the answer? This is equals to minus x to the power 5, then plus times minus. It is minus x. And here we can say that minus 1, the coefficient of x to the power 5 is minus 1 and the coefficient of x is also minus 1. So we can say that this minus 1 is a common one. So we can bring the common factor out. So if we bring the common factor out, we can write minus times x to the power 5 plus x. So this x to the power plus x, this is our original function f of x. No? So we have obtained f of minus x is equals to minus f of minus x is f of x. So if we go back with the definition,
Recording stopped.
Okay, so we were in the middle of this example.
Recording in progress.
Okay, so if a function is a even function, if function satisfy the condition f of minus x is equals to f of x, then we can call that function as a even function. And if a function satisfy the condition f of minus x is equals to minus fx, then we can identify that function as a odd function. So if we go back with the previous example, then we have start from f of minus x. Then we have obtained, if we starting from f of minus x, then we have obtained it is equals to minus f of x. So what is our conclusion? Is the given does the function is odd or even? The given function is odd function, because if we are starting from f of minus x, and then we have proved that it is equals to minus f of x. So we can conclude that therefore this f of x is an odd function. Is it clear to everyone? So do you need some time to note down this? Whatever different is ඉවරයිනේ. අවුරුද්දේ මාස දෙකක් ඉවරයි. 1 2 3 4 5 6 7 8 යවන 9 වෙනි සතියේ. තව සතියක් කාල දැම්මොත් මිඩ් නෙමෙයි තමයි කරන්න වෙන්නේ. හල්දාන්න බෑ ලබන සතියේ එක්සෑම් එක තියෙනවා. මොකද්ද? ලොන් වීකෙන්ඩ් එකක් ඉන්නේ ඔයාලටනේ සූර්යවාව ළමයින්ට එහෙම එකක් නැහැ නේ. ඒගොල්ලන්ට සඳුදා කොහොමද නිමාඩු දවස? එයාලට පොය නිමාඩුවක් හම්බෙන්නේ නැහැ නේ. ඒක නිසා ඔයාලගේ වාසිය ගැන හිතලා ඒ ළමයින්ට සාධාරණයක් කරන්න බෑ. So exam date is not changed. You will have the mid-semester examination on 7th. That's all. ඇත්තද? Enroll කියන්නේ extra curricular activities. ඒවා මාත් එක්ක මොනවනේ? ඇයි? මෙහෙනම් ඉතින් මේ ලොග් වෙලා ඉන්නේ. එයාලා රෙකෝඩ් කරනවනේ. I can change the examination date. You have to request from your dean and HOD. So if they give the permission, then I will change. මොකද්ද? ඕගොල්ලෝ මේ මගෙන් yesterday කරේ මම නෙමෙයිනේ. Okay, then I will ask Miss Ashani to continue the lecture. ලබන මාසේ තව සතියකින් මට තව lecture එකක් පටන් ගන්න ready. So I can ask someone to do your class. This is the Rabi one now. Okay then. Okay, do this example. Don't waste the time. We have to discuss some example in the tutorial as well. So try to do the remaining two questions. You have to check whether the given function is an odd function or an even function. So starting from, so here the second function is given as g of x. So you have to starting from g of minus x and then check whether it is equals to minus g of x or g of x. And then x is equal to writing the g of x is equals to the second one, g of x is equals to 1. Then h of x is equals to 2x minus x square. So you are asking to starting from g of minus x and check whether it is equal to g of x or minus g of x. Then h of x is equals to 2x minus x square. So you are asking to starting from g of minus x and check whether it is equal to g of x or minus g of x. Don't sign for others. Stop talking. So let's see this example. The second one. Second one, the function is given as g of x is equals to 1 minus x to the power 4. So we are asking to check whether this given function g of x is an odd function or an even function. So what do we need to do? We have to starting from g of minus x. That means we have to replace all the x terms in this function by minus x. So 1 minus x to the power 4. So if we consider minus x to the power 4, so we can write this as minus 1 times x. Minus 1 to the power 4. Rina eke hatharamani bale. Ekai. It's plus 1. Plus 1 times x to the power 4. It is equals to, we can write this 1 minus 1 to the power 4 x to the power 4. So this is equals to 1 minus 1 to the power 4 is equals to 1. So 1 times x to the power 4, x to the power 4. So we have obtained the original function g of x if we consider g of minus x. So this is equals to g of x. Since we have verified that g of minus x is equals to g of x, what should be the conclusion? So we can conclude that our function g of x is equals to 1 minus x to the power 4 is an odd or even. It is an even function. So have you obtained this answer by yourself? Raise your hand if you have obtained this by yourself. Okay, good. So how about third one? Or do you need some time to note down? Okay, do the third one. H of x is equals to 2x minus x squared. H of x is equals to 2x minus x squared. So you need to consider h of minus x. That means you need to replace all the x in this function by minus x. So we can write 2 times minus x minus x to the power 2. So this is equals to 2 times minus x. It is minus 2x. Then minus times minus x to the power 2. It is equals to minus 1 to the power 2 times x to the power 2. So we can write this as minus 2x minus 1 to the power 2. It's plus 1. Plus 1 times x to the power 2 is x to the power 2. So we have obtained the answer as minus 2x minus x squared. So this is not equals to h of x. We can clearly see that the coefficient of x in hx is equals to plus 2. But here it is minus 2. So let's see minus h of x. We are considering minus h of x. So minus h of x means we have to multiply the entire function by minus 1. So we have obtained minus 2x. Minus times minus is plus x squared. And we can see that these two functions are not equal. So our answer, the answer that we have obtained is not equals to hx as well as it is not equals to minus h of x. So what should be our conclusion? the given function. Therefore, we can say that the function h of x is neither odd nor even. ඒක ඔඩ්වත් ඉවන්වත් නෙවෙයි. Is it clear to everyone? Is this clear, lamai? Angila inna kattiya. Okay. How party live සුදු පාටි ලිව්වද හොඳට පේන්නේ? ඈ? සුදු? කහ? කහවට එළියයි නේද? Okay, so let's discuss why we need this odd and even function in the case of Fourier series. So if we ask him to find the Fourier series of a odd or even function, then we don't need to go through with all the three coefficients. So if we can show that the given function is an even function, then we are supposed to find a0 and an only. We don't need to find bn. So if the given function is an even function, then it is enough to find a0 and an, because bn is equals to 0 when we are considering an even function. Okay. And then here you have to be careful with these two formula. So earlier case, when we are finding a0, we have used 1 over 2l minus l to l f of x dx. But if we show that the function is an even function, then we don't need to proceed with this entire expression. We can consider 1 over l starting from 0 to l f of x dx to find a0. As well as to find an, earlier case we consider 1 over l starting from minus l to l, integration from minus l to l f of x cos something dx. So but here, since the function is an even function, we are consider this new formula 2 over l integration from 0 to l f of x cos n phi x over l dx. Similarly, if the function is an odd function, we don't need to consider these two coefficients a0 and an. We are only considering the coefficient bn, and we can use this formula 2 over l integration from 0 to l f of x sin n phi x over l dx to find that coefficient. So here, the only thing that you need to remember, I am not going to ask question from this part in the mid-semester as well as then semester. I just need to explain why you need to know this odd and even function, because for the next chapter, we need to use this odd and even function. So the thing that you have to remember is, if the function is an odd function, it provides a Fourier series with only sine terms. Fourier series with only sine terms, because the two coefficients a0 and an become 0. So we can see that if a function is an odd function, then we can obtain a Fourier sine series. So the function is an odd function, then we can obtain a Fourier sine series. Then if the function is an even function, then we will obtain a Fourier series with the constant term as well as this cosine terms. So if the function is an even function, then we will obtain a Fourier series with constant term and cosine terms. So we can conclude that if the function is an even function, the resulting Fourier series is only consists of cosine terms. So we call it as the Fourier cosine series. Is this clear? ඒ කියන්නේ function එක even function එකක් නම් Fourier series එකේ sine terms නැහැ. cos terms විතරයි තියෙන්නේ සහ constant term එක සහ cos terms විතරයි තියෙන්නේ. So function අපි consider කරන function එක f of x is an even function. Then අපිට එන උත්තරය cosine cos terms විතරක් තියෙන හින්දා අපි කියනවා ඒක Fourier cosine series එකක් කියලා. Because there are only cosine terms. So if the function is a sine function, so odd function, then the resulting Fourier series only consists of sine terms. So we call it as a Fourier sine series. That is the only thing that you need to know for the next chapter. So do you have any questions so far from this one? Everything is clear? No. ප්‍රශ්නත් නැහැ, තේරුණෙත් නැහැ. ප්‍රශ්න අහන්න තේරෙන්නේ නැද්ද? I can't even understand what is in what state that you are staying. So if you have any question, you can ask directly. Okay, so I'm going to stop this part from that stage. If you have any questions so far from the previous all those things, you can ask now before moving to the tutorial discussion. In the mid-semester examination, you will have 3 questions. So the first question, there are 2 functions that you are asking to find the Laplace transform. And then there are another 2 functions that you are asking to take the inverse Laplace transform. That is the first question. I think it's for 40 marks for the first. I'm not sure I remember the marks distribution. And the second question, you are asking to solve a ordinary differential equation using Laplace transform. And then the third question, the Fourier series problem. So it is something similar with the problem that I have mentioned. This one. The problem, it's something similar with this example number 4. So this range may be changed. So if you have some unclear things, don't stay till next Monday or Tuesday morning. So I'm available on this entire week. So if you have any question, you can come and meet me and clarify your issues. Okay. So shall we move to the problem discussion session then? Do you have any question from this chapter? Okay. So I'm going to close this one. I don't have the tutorial. This problem set with me. I only have the answers, but I have the question. Okay, then tell me what are the problems that I need to discuss. So I will share all the answers for these problems, and I mean the problems that I have assigned to submit. I will share the answers with you. Then you can check whether you can study by using that answer sheet. But I am planning to discuss some problems. Let me know what are the problems that I need to discuss. Do you have the tutorial with you? Okay, go through with it and let me know what are the problems that I need to discuss. I am asking from the question number 1, 3, 5, and the 6th one. Okay, hurry up. Tell me what are the problems that we need to discuss. ඔක්කොම තේරෙනවා නම් පාඩම ඉතුරු ගානක් හදමු අර. What are the difficult question in the tutorial number 1? Sixth one. So which part? All? Four parts in this expression, no? Okay, so let's discuss them. Are there any issues in the first one? Partial fraction decomposition? So, මම මෙච්චර කල් බලපු ටියුට් එකේ න ඔක්කොම උත්තර ටික හරි. අනිත් ඒවාත් හරි ඇතිනේ. So, මම assume කරනවා ඔයගලන්ට ඒව පුළුවන් කියලා. So the third one, the most important thing, I will provide the Laplace transformation table in the mid-semester examination as well. So you don't need to remember the formulas, but you need to remember how to obtain the answer using the table. Okay. Then question number 3, you are asking to take the Laplace transform. I hope you can do it. And the next one is the inverse Laplace transform. Anyway, let's discuss the sixth problem first. If the time permits, then go through with the remainings as well. Okay. So let's see the first part of the example number 6 chat. 3 and 6 won't matter. Okay. So we are going to do the question number 6, part A. So our problem is y double dash. So in this tutorial, all the problems were given in this formula. So, but as I remember, I put the examination question is not in this formula. Y0 is equals to 11 and y dash 0 is equals to 28. So, this is, so if we use the dy over dx or dy over dt formula, see dy over dt formula, how to write this problem? This is similar with d squared y over dt squared minus dy over dt minus 6y is equals to 0. So in the examination problem, maybe you will receive this type of problem and you need to know these two are same. Okay. So if we are asking to solve this type of ordinary differential equation using Laplace transform, the first thing that we need to do, we are assuming the answer of this problem. So if we are assuming the answer of this problem is y of t, so then we have to define the Laplace transform of the answer of this yt is equals to capital Y of s. So here, since we are dealing with time, t should be greater than or equals to 0 and s is also positive. So then, once we have defined this Laplace transform of our answer, then we are taking the Laplace transform of the both sides of this equation. So since this is the first example, I will write everything. But from the next example onward, I am not going to write these things. So we are taking when I have doing this example, I have write another one step. So since Laplace transform of y of t is equals to capital Y of s, the Laplace transform of y dash t is equals to what? S of capital Ys minus y0. So the Laplace transform of the second derivative of yt is equals to s squared capital Y of s minus s y0 minus y dash 0. So then we are taking the Laplace transform of the both side of the differential equation. So take the Laplace transform of the both sides of the differential equation, ordinary differential equation. So if we take the Laplace transform of the both sides, then we can take that Laplace transform of y double dash minus y dash minus 6y. This is equals to Laplace transform of 0. So we can write this as the Laplace transform of y double dash minus Laplace transform of y dash minus 6 Laplace transform of y, and the Laplace transform of 0 is equals to 0. So we can write, then we can replace this Laplace transform of y double dash and Laplace transform of y dash that we have by using these two formulas. So let's see, y double dash is equals to s squared capital Y of s minus s y of 0 minus y dash 0 is then minus y dash Laplace transform of the first derivative. So it is equals to s y of s minus y 0. Then minus 6 times Laplace transform of y. It is our capital Y of s, and this is equals to, all these things is equals to 0. So let's take, let's substitute. As the next step, we need to substitute the initial conditions. So the initial conditions were given, y of 0 is equals to, this is equals to 11. The initial conditions were given as y of 0 is equals to 11. Take a pen, Nanny. What's the part in the pen? A pen. To do that. Y of 0 is equals to 11 and y dash 0 is equals to 28. So the meaning of these two initial condition is when t is equals to 0, the value of y is equals to 11, and when t is equals to 0, the value of y dash is equals to 28. So we can substitute those two values into this formula. So y of 0 is equals to 11, y dash is equals to 28. So here there is another y of 0. So this is equals to 11. So we can write, by combining this all those results together, we can write s squared capital Y of s minus 11s minus 28 with a minus times this thing. So minus s y of s minus times minus plus 11 minus 6 capital Y of s is equals to 0. So then we can take all the terms which, all the ys terms together. So if we take capital Y of s out, then we can write here this is s squared. Here there is another capital Y of s term, so minus s. So here there is another capital Y of s terms, so this is minus 6. And all the remaining terms, s terms. So there is only one s terms, minus 11s, and then constant terms, minus 28 plus 11. It is plus, sorry, minus 17 is minus 17 is equals to 0. So we can write capital Y of s times s squared minus s minus 6 is equals to 11s plus 17. So we can subject this capital Y of S as 11S plus 17 over S squared minus S minus 6. So you can solve this problem in two ways. So the first way is first you have to check whether this function is can factorize or not. So if it is factorized, it is easy to find the partial fraction, easy to apply the partial fraction decomposition and obtain the answer. So if it is not possible to find the partial fractions, then you have to complete the perfect square and do the remaining operations. So here, can we factorize this one? S squared minus S minus 6. So we have the problem 11S plus 17 over S squared minus S minus 6. So this is equals to, we can factorize this as S minus 3, S plus 2. So we can define our partial fractions as A over S minus 3 plus B over S plus 2. Then we need to find this partial fractions, the value of A and B. So we can write 11S plus 17 is equals to A times S plus 2 plus B times S minus 3. So then you need to find the two coefficients A and B. So do it by yourself. The answer will be A is equals to 10 and B is equals to 1. So we have obtained an expression for this capital Y of S. The capital Y of S is equals to 10 over S minus 3 plus 1 over S plus 2. So once we have obtained this one, we are taking the inverse Laplace transform of both sides of this formula to obtain the answer for the ordinary differential equation. So this provide inverse Laplace transform of capital Y of S, provide Y simple Y of t, and then we need to find the inverse Laplace transform of this one. What is this then? We can see that in our table there is a function 1 over S minus A. Table එක ගන්න දැන්. We can write this as, by taking 10 out, L inverse 1 over S minus 3 plus L inverse 1 over S plus 2. So what should be the answer? 10 times. In our table, there is a function 1 over S minus A. So if capital F of S is equals to 1 over S minus A, the respective inverse Laplace transform is what? E to the power AT. So I'll write it here. So if we have 1 over S minus A, the respective Laplace transform is E to the power AT. So if we compare this with this one, what is the value of A here? The value of t is plus 3. The value of A is plus 3. So what should be the inverse Laplace transform of this function then? It's e to the power 3t. Then plus this one, 1 over S plus 2. So here A should be replaced by, what is the value of A here? A is equals to minus 2. So what should be the inverse Laplace transform then? E to the power minus 2t. So once you have obtained this answer, you have to provide the additional condition. Here the time should be positive. So if this part were missing in your answer, you will lose some marks. You have to be careful when you are writing your answer. You need to input this additional condition as well. So this is the answer for the first part of the sixth problem. Any question? Okay, try to do the second part then. Part B. It is similar with this one. Let's do it now. Do you have the problem with you? Maybe you have done the problem by yourself or by copying from someone when you are submitting the tutorial. Now, within the class, try to do the problem. හන්ඩක් දෙයක් කොපි කරා කියන එක එකම උත්තර ටික එකම විදියට තියෙනකොට මේමයි ළමයි ඔච්චර අතින් ලියන්න ඕනේ නැහැ එකින් එක කියලා ෆොටෝ කොපි කරන්න අපරාධ වල මහන්සිද මටත් ලේසි එතකොට ටග් ගාලා මාර්ක් එක ඔරිජිනල් එක මොකද්ද කියලා හොයා ගන්නත් පුළුවන් D 5G 5H 5E 1 minute. Oh yeah, they look it. මම ඉතින් සූර්යාවෙන් මෙසේජ් එක. Okay, so let's do the part B of the sixth question. So the problem is given as y double dash minus 4y dash plus 4y is equals to 0. So here y0 is equals to 81. Y dash 0 is equals to 39. Okay, so I'm going to skip the previous the major steps. So let's consider Laplace transform of y of t is equals to capital Y of s. Then we are taking the Laplace transform of the both side of this given ordinary differential equation. Then we will obtain. So if we take the Laplace transform of y double dash, then what is the formula? S squared capital Y of s minus මේ formulas දෙකත් exam paper එකට දැම්මා. මේක මේ අතෙන් ලියාගෙන ඉන්න ඕනේ නැහැ ඒක නිසා. S squared Y of s minus S y0 minus y dash 0. Then minus 4 times y dash, the Laplace transform of the first derivative, S capital Y of s minus y0. Then plus 4 times capital Y of s is the Laplace transform of 0 is equals to 0. So then we have to substitute the respective values. This is equals to 81. This is equals to 39. Again, this is equals to 81. So you will obtain, once you have substitute those three values, initial conditions, you will obtain an equation S squared minus 4s plus 4 times capital Y of s minus 81s minus 39 minus and minus plus 4 times 81 is equals to 0. So once you have substitute those things, you will obtain an expression for capital Y of s is equals to 81s minus 285 over s squared minus 4s plus 4. the function in the denominator, we can see that this is a square of s plus 2. So we can write this is equals to 81s minus 285 over s minus 2 to the power 2. So then we can write the expression to find the partial fraction. Since this is a perfect square, so we cannot obtain the answer by using the complete imperfect square method. We need to proceed with partial fractions. So how to write the partial fractions? 81s minus 285 over s minus 2 to the power 2. So how to write the expression for partial fractions? Hurry up, tell me. S minus 10? A over s minus 2 plus b over s minus 2 to the power 2. So then we can obtain an expression by multiplying this both sides of this expression by s minus 2 to the power 2. 81s minus 285 is equals to a times s minus 2 plus b. Then solve for a and b and then find the value for a and b. So I have obtained a is equals to 81 and b is equals to minus 123. So try to obtain this by yourself and then you will obtain our problem y of s, an expression for y of s as 81 over s minus 2 minus 123 over s minus 2 to the power 2. Okay. So we need to take the inverse Laplace transform of both sides to obtain the answer y of t. So we can write y of t is equals to 81 times inverse Laplace transform of 1 over s minus 2 minus 123 inverse Laplace transform of 1 over s minus 2 to the power 2. Okay. Now tell me 81 times inverse Laplace transform of 1 over s minus 2. So if it is 1 over s minus a, then e to the power at. So here is 1 over s minus 2. So what should be the answer? Is e to the power 2t. Then how about next one? Tell me is the answer for the next one. Ushani nani idada? Okay. So if we have 1 over, so I will write it here, 1 over s squared, then what should be the respective inverse Laplace transform? 1 over s squared නම් මොකද inverse transform එක වෙන්නේ? It's t. No? මෙතන තියෙන්නේ හැබැයි මොකද්ද? s 1 over එතන තියෙන්නේ 1 over s squared නෙමෙයි 1 over s minus 2 squared. 1 over s squared තිබ්බනම් එන්නේ t. හැබැයි මෙතන s කියන එක රීප්ලේස් වෙලා තියෙන්නේ මොකෙන්ද? s minus 2 ගෙන්. එතකොට මොකක්ද වෙන්නේ? මොකක් හරි තියෙන f of s කියන එකක s කියන එක s minus a ගෙන් replace වෙලා තියෙනවා නම් original function එකේ Laplace transform එක අපි e to the power at ගෙන් ගුණ කරනවා. f of s තියෙන එක f of s minus a විදිහට නම් තියෙන්නේ. f of t කියන එක e to the power at ගෙන් ගුණ කරනවා. දැන් මේකේ f of s කියන එක වෙන්නේ 1 over s squared. හැබැයි ඒකේ s කියන එක replace වෙලා තියෙන්නේ s minus 2 ගෙන්. එතකොට මොකද්ද වෙන්න ඕනේ? අපි මේ original function එක t කියන එක මොකෙන්ද ගුණ කරන්න ඕනේ? s කියන එක s minus a ගෙන් replace වුණොත් e to the power at ගෙන් ගුණ වෙන්නේ. එතකොට මෙතන s කියන එක s minus 2 ගෙන් replace වෙලා තියෙනවා. එතකොට මොකෙන්ද ගුණ වෙන්නේ? e to the power 2t. මොකද මෙතන value එක a ගේ value එක වෙන්නේ 2යි. ඒක so we can obtain the answer 100 minus 123 t e to the power 2t. So to complete this answer, we need to write t should be greater than or equals to 0. Is it clear? තේරුණාද ළමයි? Okay. Then you need some time to note down. වෙන වැඩ කරලා දැන් බොරුවට අවතුරට ඕනේද? අවතුරට ඕනේද? Okay, try to do this third one, part C, 6th question, part C. So we are going to do the problem number 6, part C. The problem is y double dash minus 4y dash plus 3y is equals to 6t minus 8. And the initial conditions were given. Y0 is equals to 0 and y dash 0 is also equals to 0. So here also, the first thing that we need to do is we need to define the Laplace transform of the answer as capital Y of s. Then we need to take the Laplace transform of the both side of this differential equation. So it provides s squared capital Y of s minus s y0 minus y dash 0 minus 4 times s capital Y of s minus y0 plus 3 times capital Y of s is equals to, how about the right hand side? 6t minus 8. So if it is 6t, if it is t, what should be the Laplace transform of t? T now, what is the Laplace transform of t? 1 over s squared. Since it is 6t, so what should be the Laplace transform then? 6 over s squared minus, if the function is 1, then the respective Laplace transform is 1 over s. So here the function is 8. So what is the respective Laplace transform then? 8 over s. So once we have obtained this expression, we can substitute the initial conditions. So here y0 is equals to 0. Sorry, y0 is equal to 0. Y dash 0 is also equals to 0. And again y0 is equals to 0. So then you will obtain the expression s squared minus 4s plus 3 capital Y of s minus 0 times s. It provides 0 minus 0 again plus 4 times 0 again 0. This is equals to 6 over s squared minus 8 over s. So we can write this by taking a common denominator. S squared is equals to 6 minus 8s. Then we can write this capital Y of s is equals to 6 minus 8s over s squared times s squared minus 4s plus 3. So you need to find the partial fractions. S minus 8s over s squared minus 4s plus 3. This is equals to, okay, tell me the expression for the partial fractions. This one can be factorized, right? So I will separate the factors and write it here. S squared minus 4s plus 3. It can be factorized as s minus 3, s minus 1. So we can write the expression for the partial fractions as a over s plus b over s squared plus c over s minus 3 plus d over s minus 1. So once you have, then you need to find all these 4 coefficients. So I'm not going to do that one. We can obtain the expression 6 minus 8s is equals to a times s minus 3, s minus 1 plus b times s minus 3, s minus 1 plus c times s squared, s minus 1 plus d times s squared, s minus 3. So you can substitute some values and obtain the value for a, b, c, d. So then you will obtain a is equals to 0, b is equals to 2, c is equals to minus 1, and d is equals to 1 as your answer. So then we can write our capital Y of s is equals to, since a is equal to 0, we can omit this part. So 2 over s squared minus 1 over s minus 3 plus 1 over s minus 1. So to find simple y of t, that means the answer of this given differential equation, we need to consider the inverse Laplace transform of this capital Y of s. So it provides 2 times inverse Laplace transform of 1 over s squared minus inverse Laplace transform of 1 over s minus 3 plus inverse Laplace transform of 1 over s minus 1. Tell me the answer. 1 over s squared ki inverse එක මොකක්ද? It's t minus this one 1 over s minus a තිබ්බොත් e to the power at. මේක තියෙන්නේ 1 over s minus 3. So what should be the answer? E to the power 3t. Then plus here 1 over s minus a තිබ්බොත් e to the power at. හැබැයි තියෙන්නේ 1 over s minus 1. So what should be the answer? E to the power t. So to complete this answer, we need to write this t should be greater than or equals to 0 as well. Okay. Try to do the last one. I will give some time. Wait a minute. Ratupana Kirindlamar. Sign karane huh? Caption. Okay, so the last one. Part D. It's y double dash y plus 9y is equals to 10 to the power, 10 e to the power minus t. And initial conditions are y0 is equal to 0, y prime 0 is also equals to 0. Okay. So here also we need to define, first we need to define what is capital Y of S. It is the Laplace transform of y of t. And then you need to write the expression for the Laplace transform of y dash and y double dash. And then you need to take the Laplace transform of the both side of this differential equation. So you will obtain expression s squared capital y of s minus s y0 minus y dash 0 plus 9 capital Y of s is equals to 10. What is the Laplace transform of e to the power minus t? If it is e to the power t, then, if it is e to the power at, then 1 over s minus a. So if it is e to the power minus t, then what should be the answer? 1 over s minus a. So we can write it as s plus 1. Since it is e to the power minus t, it should be 1 over s plus 1. So we can substitute the initial conditions. This is 0. This is 0. So we will obtain the expression as s squared plus 9 times capital Y of s is equals to 10 over s plus 1. So we can write capital Y of S as 10 over S plus 1 S squared plus 9. Then you need to find the partial fractions. How to write the expression to find the partial fractions here? The first one is a linear factor, but it is not repeating. So we can write it as A over S plus 1. And this one is it linear or quadratic? Quadratic factor, and it is not repeating. So how to write the numerator then? Denominator is S squared plus 9. The denominator is BS plus C. So we can write 10 is equals to A times S squared plus 9 plus BS plus C times S plus 1. So find those three coefficients. Then it will provide A is equals to 1, B is equals to minus 1, and C is also equals to 1. So you can write capital Y of S is 1 over S plus 1 minus minus 1 over S squared plus 9. So then we can rewrite this as 1 over S plus 1. So let's see, this is plus, this is minus, and this is the original way. So we can write this as minus S over S squared plus 3 squared and plus over S squared plus 3 squared. So if the value in the, okay, let's discuss one by one. This one, what should be the inverse of this one? Just Laplace transform of this one. So to find simple Y of t, we need to take the inverse Laplace transform of this capital Y of S. So what should be the first one? The inverse Laplace transform of 1 over S plus 1 minus the inverse Laplace transform of S over S squared plus 3 squared plus inverse Laplace transform of 1 over S squared plus 3 squared. So let's consider term by term. First one, inverse of 1 over S plus 1. If it is 1 over S minus 1, if the function is 1 over S minus A, then what should be the Laplace transform inverse? E to the power AT. So our function here is 1 over S plus 1. So A should be replaced by what? A මොකකින්ද මෙතන වෙනස් වෙලා තියෙන්නේ? A සමානයි මොකක්ද? minus 1 plus 1 නෙවෙයි minus 1. So what should be the inverse Laplace transform of the first part of this function? E to the power minus t. Okay, then next part, there is a minus sign there. S over S squared plus 3 to the power 2. S over S squared plus 3 to the power 2. අපිට තියෙනවා නම් S over S squared plus omega squared. Then that is the Laplace transform of cosine omega t. But here we have S over S squared plus 3 squared. So the value of omega is key. Value of the omega is what? It is 3. So we can write this as minus cosine 3t. And the next one, if we have omega over s squared plus omega squared, then the respective Laplace transform is sine omega t. So here, if we compare the denominator with this one, what is the value of omega? If we compare this denominator with this denominator, what is the value of omega? 3. But in the numerator, it should be another omega. But here there is no 3 term there. So we have to convert this into 3. So that means we need to multiply the numerator by 3. If we are multiplying means we need to divide as well. So we have to put 1 over 3 into the front. So what should be the answer then? Plus 1 over 3. This one. It is sine 3t. So once you have obtained this answer, to fulfill your answer, you need to write this additional condition t greater than 0 as well. Okay. So that is the answer for the question number 6. Since we have another 25 minutes. Okay. What are the other questions? So someone asked to do the third question. What is the third one? Laplace transform. One asked to do third one, and you are asking to do 5 parts of equation. 1D, 5G, 5H, 5E. 1D. පළවෙනි ගාන නම් හදන්නේ. පළවෙනි එකක් ගන්න. Okay, let's do the third one. Let's quickly go through with the third one. එපාට පේනවද? පේනනේ. ලස්සන. Okay, so let's move on with the question number 3. Question number 3, part 1. We are asking to find the Laplace transform of f of t is equals to 3 e to the power minus 5t plus 3 plus e to the power 3t minus 4t to the power 4 plus 5. Okay. Tell me, what is the Laplace transform of this one? We can write capital F of s is equals to e to the power at now. If the given function is e to the power at, then the Laplace transform is 1 over 1 minus s. So, මෙතන තුනක් තියෙනවා. So, we can keep this tree as it is. And if it is e to the power at, then it should be 1 over 1 minus a. But here a by what? Minus 5. Then plus here e to the power 18 1 over 1 minus 1 over s minus a. හැබැයි මෙතන තියෙන e to the power 3t. So 1 over s minus 3 minus 4 e to the power t to the power 4. e to the power n නම් මොකද formula එක? n factorial over s to the power n plus 1. So we can write this 4 here, n is equals to 4. In fact, 4 factorial over s to the power 4 plus 1. And finally 5. එකයි නම් 1 over s. So behind 5 over s. So you can simplify this one. To obtain the final answer, we can write s over මෙතන ඍණයි ධන වෙනවා. s plus 5 plus 1 over s minus 3 minus මේක ඔයගලන්ට ඕනනම් මේ 4 factorial කියන එක multiply කරලා ගන්නත් පුළුවන්. කොහොමද 4 factorial හොයන්නේ? Tell me how to find the 4 factorial. To find the 4 factorial, we need to multiply 4 times, 3 times, 2 times, 1. And since it is 4 times 4 factorial, we need to multiply the answer again by 4. So 4 times 3 is 12. 12 times 2 is 24. 4 times 24, it's 96. So we can write the answer as minus 96 over s to the power 5 plus 5 over s. And here s should be some positive value. S should be greater than 0. Okay, this is the answer for the first part. The f of t is given as 3 cosine 4t minus 5 sine 3t plus 2 cosine 10t. Okay. So let's recall the expressions for cosine and sine omega, cos omega t. If it is cos omega t, then what should be the respective Laplace transform? S over s squared plus omega squared. So if it is sine omega t, then omega over s squared plus omega squared. So we are going to use these two expressions to obtain the answer for this problem. So let's see, we are asking to find capital F of S. This is equals to 3. We can keep 3 as it is. Cos 40. So we have to compare this with cos omega t. So value of omega, we are comparing cos 40 and cos omega t. Omega ke value එක මොකක්ද? Omega ke value of omega is equals to 4. So what is the Laplace transform then? S over s squared plus 4 to the power 2. Then next one, minus 5 times sine 3t. Sine omega t na omega bedima s varge dana omega varge. But here it is sine 3t. Omega කියන්නේ කීයද එතකොට? 29. So how to write the expression? 3 over s squared plus 3 square. Last one, 2. දෙක වතාවක් cos 10යි t. cos omega t එක වෙනකොට 10 omega කියන්නේ 10යි. So answer is s over s squared plus 10 to the power 2. So you can write the final answer by simplifying this. Capital F of s is equals to 3s over s squared plus 16 minus 15. 5 times 3 is equals to 15 over s squared plus 9 plus 2s over s squared plus 100, and s should be positive. So this is the answer for the second part. Part C. F of t is given as shin cos 3t t. So let's consider this cos 95 t first. So we are going to consider this part first. I will use another color, this one. We are going to consider this part first. So I will write the answer here. So if we have to find the Laplace transform of cos 95t, what should be the answer? The Laplace transform of cos 95t. Cos 80 නම් මේකනේ. හැබැයි අපිට හොයන්න දෙන්නේ cos 95t. එතකොට a ගේ value එක මොකද්ද? 95. So we have to replace a by 95 here. 95 to the power 2. But this is not the thing that we are asking to find. So this cos 95t කියන එක ගුණ වෙලා තියෙනවා e to the power 80. ඒ කියන්නේ අපි if we consider this cos 95t, let's see if we consider this cos 95t is as gt, then in our problem gt is multiplied by e to the power 3t. And let's see, the Laplace transform of this gt is equals to capital G of s. And it is that one. So in our first translation theorem or first shifting theorem, it states that if we have a Laplace transform of the function f of x as capital F of s, and if we multiply the function f of s by e to the power 80, then the respective Laplace transform is as capital F of s minus a. දැන් මෙතනදී වෙන්නේ අපි මේක ගන්නවා gt කිය. gt ගුණ වෙලා දිනවා e to the power 3t. gt e to the power 3t එකෙන් ගුණ වෙලා දිනවා gt ගේ Laplace transform එක වෙන්නේ capital G of s. So if we are asking to find the Laplace transform of this e to the power 3t times gt, what we need to consider is g of s minus මොකද්ද value එකේ s e to the power 80 ගෙන් ගුණ වුණා අපි consider කරන්නේ f of s minus a. මෙතන ගුණ වෙලා තියෙන e to the power 3t ගෙන්. එතකොට අපි consider කරන්න ඕනේ s minus 3. So that means we need to replace all the s terms in this expression in gs by s minus a to obtain the answer. So our answer should be 2 times s minus 3 over s minus 3 to the power 2 plus 95 to the power 2. And here it should be city. තේරුණාද? මොකද වෙන්නේ කියලා? first shifting theorem එක තමයි apply වෙන්නේ. ඒ කියන්නේ අපි මුලින් කරන්නේ මේ e to the power 3t කියන එක අමතක කරලා ඉතුරු වෙලා තියෙන function එකේ Laplace transform එක හොයනවා. ඊට පස්සේ ගුණ වෙලා තියෙන e to the power 80 කියන එකකින් නම් මේකේන උත්තරේ s අකුරු ටික ඔක්කොම s minus a ගෙන් replace කරනවා. So that's the thing that we supposed to do. Okay, so I think in the part E also we have to use this thing. So let's do that one as well. Part E. F of t is equals to 3 e to the power minus 5t sin 2t plus 5t to the power 3. So we are asking to find the Laplace transform this one. මේකේ මෙන්න මේ පළවෙනි part එක අපි හිතුවොත් we can see that in the first part we have a function sin 2t and ඒක ගුණ වෙලා තියෙනවා e to the power minus 5t ගේ. එතකොට sin 2t ගේ Laplace transform එක මොකද්ද? sin 2t ගේ Laplace transform එක මොකද්ද වෙන්නේ? omega ඉන්නේ කොහමද sin 2t නම් sin omega t නන්නේ omega sin 2t omega ගේ value එක 2යි. එතකොට වෙන්නේ 2 over s squared plus 2 squared. sin 2t විතරක් ගත්තොත් මෙහෙමයි එන්නේ. හැබැයි මෙතන තියෙන්නේ sin 2t විතරක් නෙමෙයි. ඒක ගුණ වෙලා තියෙනවා e to the power minus 5t ගේ. මේක මේ sin 2t හරි whatever function එක e to the power a t ගෙන් ගුණ වෙලා තිබුණොත් we are going to replace s by s minus a. But in this example, the function should be multiplied by function was multiplied by e to the power minus 5t. So what we need to do? We need to substitute s by what is s by s minus a. The value of a here, if we compare these two, value of a is minus 5. So we need to substitute s by s minus 5. That means we need to substitute s by s plus 5. So to obtain the answer, we can write capital F of s by keeping this 3 as it is. Sin 2t නම් ඉන්නේ මේක. හැබැයි ඒක minus so e to the power minus 5t ගෙන් ගුණ වෙලා තියෙන හින්දා we need to replace all the s in this function by s plus 5. So you will obtain the answer as 2 over s plus 5 to the power 2 plus 2 to the power 2. Then plus 5 times t to the power 3. What is the Laplace transform of t to the power 3? It is 3 factorial over s to the power 4. So if you need, you can simplify. So I will simplify that as well. You will obtain the final answer as 6 over s plus 5 to the power 2 plus 4. 3 factorial can high 30 over s to the power 4 and s should be positive. Okay. So I have discussed 2 complete examples. So I have done all the parts of the example number 3 and example 6. So I will share the answers of example number 1 and 5. And practice with this. In the examination paper also you have this type of problems. So maybe you have, no. I think you need to use the first shifting theorem. That means the question you will get is something similar with part E or part D. DOE, last 2 part. හරියටම මතක නැහැ first shifting theorem apply කරන එකක් තියෙනවා කියලා මතකයි. මොකද paper එක හදලා ගොඩාක් දවස් මන්දේ. නේ මට හරියටම මතක නැහැ කොහොමද දැම්මේ කියලා. So anyway, practice with these type of problems for the first 2 questions, and for the last question, I have already mentioned what is the type of the problem. Okay, then if you have some questions regarding or something unclear, you can feel free to contact me at any time, so I will help you. And I will share those documents when I have go back with the faculty. If I forget, please remind me. And okay, so let's meet on the examination will be held at 8:30, not 8:30. So the venue will be informed by your faculty. Most probably it will be held on the examination hall, but I'm not sure. So it will be informed by the faculty. Okay. Do you have any questions, any things to clarify or discuss? No? Okay, so then let's stop the session for today. And thank you.
Recording stopped.